So we're going to have a look at some special triangles in trigonometry that allow us to solve, to find angles and side lengths in triangles without the use of a calculator. It can only occur in some pretty specific triangles, and these are special triangles. The first one is a 30, 60, 90 triangle, and the second one is an isosceles right angle triangle. So let's have a look at some examples. Okay, so here we've got a 30, 60, 90 triangle. So we've got an angle of 30, 60 and 90 degrees. Now what's special about this triangle is that it has its side lengths in a specific ratio. And that ratio is 1 to 2 to root 3. And they happen in this order. The 1 is opposite the smallest angle, which is 30 degrees. The 2, which is the largest number, is opposite the largest angle, 90 degrees. And the root 3, which is actually between 1 and 2, is opposite the 60-degree angle. So let's have a look at an example. Here I've got a triangle with an angle of 30 degrees and 90 degrees. So that means that the missing angle must be 60 degrees. So I can see that I have a triangle that's 30, 60, 90. So I can use the ratios to help me find missing sides. So the first thing I'm going to do is to label my ratios on the appropriate sides. So the side opposite the 30 degrees is the smallest of the ratios, 1. The side opposite the largest angle, the 90 degrees, is the largest, 2. And my other side, which I actually don't need in this example, is root 3. Okay, so now I can see that the ratio of side x to 15 is actually 1 to 2. So therefore x must be 7.5 units. I think in this case we're talking centimetres. Let's have a look at another problem. Here we've got a triangle where we're given a hypotenuse of 2 root 2 and an adjacent side of 2. And I'm wanting to find the missing angle theta. Now in this case, I need to find the angle. What I'm going to do first is I'm going to get that other side and see if I've got the side lengths in the ratio 30, 60, 90. Check if it's actually a 30, 60, 90 triangle. So let's use Pythagoras' theorem to help us do that. So, oops, I'll change to a pen. A squared plus b squared equals c squared. So then I can say, we'll label our sides, A, B, C. I can say a squared plus 2 squared equals 2 root 2 all squared. So then a squared plus 4 equals 2 root 2 times 2 root 2. So a squared plus 4 equals 4 times root 4. So a squared plus 4 equals 4 times 2, which is 8. So a squared equals 8 minus 4, which is 4. So a equals root 4. So a equals 2. Okay, and I'm going to put that information on my triangle, write in a equals 2. So let's have a closer look at our sides to see if they fit the ratio 1 to 2 to root 3 and if it's a 30, 60, 90 triangle. So we've got two sides of 2 and a side of 2 root 2, and we can see that they are not in the ratio 1 to 2 to root 3. But what we do have is two sides the same. So that means we have an isosceles triangle. So we've got an isosceles right angled triangle. So what do we know about isosceles triangles? we know that I have two sides the same and two angles the same. So therefore, if this angle is 90 degrees, my missing angles must both be 45. So therefore I can say from my problem, theta equals 45 degrees. In this problem we're asked to work out the area of the triangle. And we know that our formula for the area of a triangle is the base times the height divided by 2. So we need the perpendicular height of this triangle, which we don't have, but let's draw it in. If I can get my pen to work. Okay, so I've drawn in the perpendicular height, and I'm going to label that with a 90 degrees. So I can see now that here I've actually created a 30, 60, 90 triangle. I'm just going to redraw that for now so that I can work with that a bit closer. Label on my information. I know that this is 6 centimetres. I know that this is 60 degrees. I don't know that this length down the bottom, so I'm going to call this B, and I don't know this perpendicular height, which I need to work out the area. I'm going to label that A, and I'm going to label my other missing angle as 30 degrees. Okay, so let's think about the ratios that we know in a 30, 60, 90 triangle. So 1 will be opposite the smallest angle. 2 will be opposite the largest angle, and root 3 is the other one opposite the 60 degrees. So now I can see that my scale factor is 3. I've multiplied 2 by 3 to turn it into 6. So all of my sides must be 3 times larger than the initial ratio. So that means that B will be 3. 1 times 3 is 3. And that means A will be 3 times root 3. Okay, so now we've got the perpendicular height of our initial triangle. It is 3 root 3. And we can put that information into our formula. So area equals the base, which is 16, times by the perpendicular height, which is 3 root 3, all divided by 2. And then we can simplify that. 16 times 3 is 48, so I've got 48 root 3 over 2. And I can cancel down, so I've got 24 root 3 centimetres squared. And we're done.